year 2046, war broke out among the nations of the world. This war devastated over a third of the world, killing hundreds of millions of people. But the world completely changed in the year 2048, when one nation decided to use a nuclear missile. In retaliation, more nuclear weapons were fired, and the entire world was laid to waste. Now, what is left of the human race is surviving by living underground, away from the radiation left by the nuclear fallout.
We're here outside at the local water source. We're hoping to take some samples to check to see if radiation levels in the water has gone down enough that we're going to be able to test the use of the drinking water. So take a look.
These chemical engineers are risking their lives in the highly radioactive environment that is now the Earth's surface. The surviving humans have been living off of underground water up to this point, but as this supply runs low, it is now necessary to find other sources. Due to the high radiation levels outside, our engineers must be protected by wearing proper equipment to ensure their safety. Here, we see these engineers collecting samples in order to determine the radioactivity levels of the water and surrounding area. The water is not the only thing to be collected. The nearby soil and plant life are to be tested as well, in an attempt to study how the Earth is adapting to the changes caused by the radioactivity. The engineers must be extra cautious in this particular area due to the increased risk of attacks from radioactive bears, who have lost all fear of humans. And so it is important that they work together as a team to prevent this risk. It has been theorized that a newly designed membrane created from lead would be able to purify the outside water from all radiation. The samples obtained here will be used to test this technology. Now that samples have been taken of the water in nearby area, it's time to head back to the underground lab. These engineers have surely been exposed to enough radiation. The engineers are anxious to try out their new technology to see if it works. Here we are in the underground makeshift laboratory built by our chemical engineers to conduct their research. Thanks to the renowned resourcefulness of chemical engineers, this lab is fully operational, although it may not appear to be. These vents are used to transport air between the underground greenhouse and the lab.
Here we are back in the lab. First we had to go through our deradiationizer. But now that we're here, we're going to test these samples that we took while we were out there. We took some water samples at the source. We took some soil samples near the source. And we took some plant life samples while we were out there. We're hoping that these will be able to give us a good idea of the radiation levels in the area. So hopefully we can end up using drinking water. Now, we're going to start off testing samples for the water because it's most important to us. We only have a limited supply of stagnant water down here to live off of. So if we can get this water to be drinkable, it'll really help us out. Now, it's very important that while I'm doing these, I don't spill any, because this could still be very radioactive. Now we have our samples, let's go run some tests. Here we are in the RRL, the Radiation Reduction Lab, to run our tests. Recently, we've developed a microscopic lead membrane technology. we're hoping that this technology will be able to successfully filter out the radioactive particles from the contaminated water. Now, unfortunately, the side effect of this technology is that we end up with high concentrations of lead in our drinking water. So, to get this out, we're going to have to use a lead filtration system device. And now that we've run our tests, let's go see what we found. And now that we've run our tests, it worked!
We don't know exactly what will happen in the future, but chemical engineers have been saving the world for the past 100 years, and without a doubt, they'll be saving it for 100 more. So there is confidence in knowing that no matter what weapons chemical engineers create, we'll always be able to fix any problems that arise from them.
And now we're going to take multiple samples with the samples that we took. Here we are on Double RL.
Oh shit.
Here we are on Double RL lab. And run it through that lead device, the radiation reduction lab, to test our sample.